Yes, sir. Let's.
Yeah. Hi, everybody. Welcome to iitiansgateclasses classes. I'm Dheeraj, and today we are going to discuss a question from Data Science and AI sample paper, and the topic is going to be calculus and optimization. Okay. So optimization, as in the syllabus, it is mentioned that optimization for single variable, right? So this session is on calculus, okay, and this session you can see here. This is a, you can say, section B here, calculus and optimization. According to syllabus, this is going to be your third topic. Okay, so we are going to solve questions. See, in the sample paper, 1 mark question, there are 2 questions, and 2 mark question, there are four. You can say 4 questions. So total 10 mark you can expect from this paper, right? So we are going to take the very first question from calculus and optimization, right? So today I will also discuss what is the meaning of optimization and which topic you have to focus on, right? So please join the session, and guys, you can also respond here. In fact, all the GATE aspirant can join and learn mathematics. So the very first question is there according to the sample paper. This question is asked from the limit, okay? The topic, you know, limit, okay? And the value of limit x tending to 2 root x minus root 2 by x minus 2 is, okay? So I think what you can do here, the very first thing that you have to check here is whether it is a 0 by 0 form or not, right? So if you plug 2 here, you will see that root 2 minus root 2 by 2 minus 2, which is nothing but 0 by 0 form, right? So since it is a 0 by 0 form, so you can apply the L'Hopital rule. What L'Hopital rule says that you have to differentiate numerator and denominator until it becomes free from 0 by 0 form, because this is kind of risky situations, okay? In the class I always say it is going to be kind of risky situation, or you can say sometimes we have got infinity by infinity form, okay? Many forms are there, indeterminate form, you can say, right? So let us now try to differentiate numerator and denominator by L'Hopital. So limit x tending to 2, okay? Differentiate root x. What is the differentiation of root x? That is going to be 1 by 2 root x, okay? Everybody knows that. And differentiation of constant is 0, so minus 0 upon differentiation of x is going to be 1 minus 0, right? So it becomes limit x tending to 2, okay? And here you can plug now, you know, 2 root x, okay? So you can see here now you can plug x equal to 2 because now it is free from 0 by 0 form, okay? So it is very simple question that was given in the sample paper. So it is kind of clear indication that the question will be very simple provided your concepts would be clear, right? So 1 by root x is going to be what? You plug root 2 x equal to 2 only, so this is going to be your limit answer is going to be 1 by 2 root 2. So the option for this question is C, right? So you guys can also comment in the chat box, as this session is live here, okay? So let us move to next question. So always look for 0 by 0 form or infinity by infinity form and go for L'Hopital. L'Hopital says that you know, you have to keep on differentiating numerator and denominator such that it becomes free from 0 by 0, right? Okay, so let us move to next question. This question is again from calculus, okay? uh, or you can say this question is from optimization. See, in the GATE data science and AI syllabus, they have mentioned that optimization for single variable, right? Optimization for single variable is nothing but you have to find maxima or minima, right? So you can say this question is from calculus as well as optimization, right? So optimizing is nothing but you have to maximize the function or minimize the function, right? So there is there are many application of optimization in case of you can say machine learning and all, right? So the function here given is f of x equal to 1 plus x square, okay? Has option is saddle point at x equal to minus 0.5, maxima at x equal to minus 0.5, minima at x equal to minus 0.5, and f dash is this, right? So which option is going to be correct? So the simple algorithm, okay, in order to investigate whether the function is minima or maxima, okay. So the very first step, whenever fx is 0, right? These things are taught in the class always, okay. So what we can do here is we can find out the first derivative here, f dash x. What is f dash x, guys? It becomes 2x plus 1, right? Simply. Now the moment you have got the very first derivative, you can find out the stationary point. Okay, so in order to find stationary point here, stationary point, okay, what we can do here is you can equate this guy, 2x plus 1 equal to 0. So here x is going to be minus 1 by 2, which is nothing but 0.5. I believe this is fine till this point. Okay, the very first step, okay, whenever any function is given and we have to investigate whether it is a minima or maxima, right? So we have to differentiate, we have to take the first derivative and find out the stationary point, or you can say critical points, right? So x equal to minus 1 by 2, that is minus 0.5. So only one stationary point is there. Now, in order to investigate whether it is minima or maxima, you have to go for second derivative also. Second derivative f of x you can find out. So it becomes 2 only, right? So if you're going to plug this, you can say that at this stationary point 0.5, okay, if this comes out to be positive, right? It is coming out to be positive. It means there will be a minima, right? There will be a minima. And also one more concept that I just want to highlight here is that, guys, if the stationary points are not real, remember, if they are real, there will be some minima or maxima. There is a possibility of minima or maxima. But if the stationary points are not real, okay, suppose you have taken the first derivative and you got the stationary point, they are not real, they are imaginary, right? So there is a remote chance that you will get minima or maxima, right? There will not be any minima or maxima. That is the very important concept that you should know, right? And this is useful for other branch of engineering as well, right? So since you got here at x equal to minus 0.5, this second derivative is going to be positive. It means there is a minima. So which option is going to be correct here, guys? Option C will be correct for this question, right? So whether you put minus 0.5 here or you do not put, still it is going to be positive only, right? So for all the value here, you see this is positive, right? So there will be a minima. And in case suppose second derivative would have been what, negative, then there should have been maxima, right? I hope this makes sense. So this is the question here, question number 19, and the correct option is gonna be C, right? So you should know this perfect algorithm, right? So whenever you want to find minima or maxima, so you have to go for first derivative, then second derivative. Okay, fine. And this is one of the clear question, right? You have got this question, and this question is one of the amazing question, right? Where your conventional approach is going to be fail, right? Because this question, you see, the function f of x equal to 1 plus 2x plus 3x square plus 2026 x to the power 2025. Okay, here the order of the polynomial is huge, you can say, right? So if you're going to find the first derivative, and what you have to investigate here is which of the following statement is true. So you have to investigate whether f of x has global minima, f of x has global maxima, f of x does not have global minima, f of x is not continuous, right? So which option is going to be true here, right? So this is a question, you can say this question is from optimization, right? Optimization of for single variable. Okay, single variable. So if you don't know the optimization, right, you have to minimize or maximize the function, right? But what problem is there? You see here, this polynomial has got a very huge degree here. You see 2025, right? So if you're going to differentiate this and try to find the stationary points, you will not be able to find the stationary point. Okay, a conventional approach is going to be fail here, right? So what you can do here is you have to remember, this is very important point that I'm going to tell you. As long as this you can see here the polynomial has got the degree here, that is 2025, which is odd. So it is nothing but an odd order polynomial, right? You can say odd degree polynomial. Okay, in the question it is given as odd degree polynomial. Okay, so if you have attended my class, what you will do here is, since it is an odd degree polynomial, So what you can do here is you can consider, right? You can consider this f of x, right? Okay, any small odd degree, you can say odd. Here I should write odd order, you can say, or odd degree polynomial. Okay, let me erase this. Okay, so I'm very sure that many of you might have started differentiating and finding the first derivative. Okay, but what you have to do here is you have to optimize the problem, right? Since the polynomial has got a very huge degree, right? So this is where you have to optimize. You have to, what you have to do here is, you can consider any small order polynomial, and whatever concept will be applicable, for odd degree polynomial, for small, you can say, for small degree polynomial, the same concept is going to be applicable for higher order degree polynomial as well, but provided that should be odd here, right? So what we can do here is we can consider, so here 1 plus 2x plus 3x square, and we can take next is nothing but 4x cube, right? Okay, so let us consider the function here. Okay, consider f of x, new f of x, you can say 1 plus 2x plus 3x square plus 4x cube, right? 4x cube. You can forget about higher order terms, okay? Because if you're going to see whatever conventional approach, right? First you have to differentiate, then you have to find the stationary point, then you have to find then you have to go for second derivative test, and then you have to put a stationary point, okay? And then you have to check whether that second derivative is positive or negative, right? So in this case, as long as this polynomial is concerned in the exam, if you're going to follow the conventional approach, life is going to become difficult. Yes, all in one. Yeah, it is correct. Up to x cube we can take here, right? Okay. Now you can follow the conventional approach, whatever Dheeraj sir has taught you in the class, right? So what you can do here is f dash x, you can do here f dash x. Now you can differentiate this, right? So it becomes, this is nothing but 2 plus 6x square, then this is 12x square. I believe this is fine for all, right? Now you can find the stationary point. Let us calculate the stationary point here, guys, for you. Okay, so what you can do here is you can equate this guy. Okay, sorry, I think this should be nothing but okay, because we have differentiated, so it should be 6x only, right? Fine. So what we can write here is 12x square plus 6x plus 2 equal to 0. Now you can take 2 outside, right? So it becomes 6x square plus 3x plus 1 equal to 0, right? You can take 2, and your polynomial become like this, okay, after differentiation, f dash x, right? Now you can find the stationary point. So how to find x equal to minus, since it is a quadratic equation, so you can use minus b plus minus square root of b square minus 4ac by 2a, right? I believe everybody knows this formula. So you can put minus 3 plus minus square root of b square, that is 9 minus 4ac, that is 24 by 2 times 6, right? So this becomes what? Minus 3 plus minus square root of what? Since this is nothing but if you're going to compute this, so it will be nothing but minus 15. Okay, yeah, minus 15, and this is nothing but 6. Fine. So this is nothing but what? Minus 3 plus minus j root 15 by 6. Okay. Now what you can comment here is that in the very beginning, when I was solving a very simple question, right? So as you can see here, you can say that what you can say here is that if you're going to plug this, right? Since stationary points are imaginary, right? Since stationary points, okay, are imaginary, okay, so you can directly claim that there will not be any maxima or minima. Okay, there is not going to be maxima or minima, this is for sure, guys. Okay, this is very important concept. Okay, so there will not be any maxima or minima because the stationary points are imaginary, they are not real. Okay, they are not real. Okay, that is very important. So here first option is wrong, right? Second option is going to be wrong. Okay, and they have said that f of x is not continuous. All the polynomial in x, this is the polynomial in x, right? This is polynomial in x and it is continuous. So which option is going to be correct? The option C will be correct here. Okay, so if you are ready to optimize the problem, okay, the way Dheeraj sir has suggested you, you will be able to get the correct answer. So we know the algorithm. What we know, we have to suppose any polynomial is given, any function is given. So we have to go for first derivative, right? And we have to investigate the stationary points. Then we have to go for second derivative. Okay, so in the first go, you are going to do the same only, right? So this is the right choice. Okay, so in any branch of engineering, this kind of question might be asked. Okay, from IRC Bangalore, they might surprise you, right? So you have to be ready. ये concept तो आपको पता होना चाहिए, ठीक है? This is the very important concept. So concept is what from this question? Concept is, if the stationary points, okay, are, you can say, found to be imaginary, right? Then you can claim that no max and no min direct. Okay. So if any higher order polynomial will be given in the questions, you have to consider for a small degree polynomial and try to investigate minima and maxima. That's it. Okay. So answer for this question is C. Fine. I hope this makes sense to all guys. Let us move to next question. So consider following question. We have got smooth twice. Okay. Question. Statement A is given here. A smooth twice differential function can have global minima. Okay. All smooth twice differential function have global minima, right? So option A are what P and R are true. Okay. P is true and Q is false. Okay, and P is false and Q is true. So can somebody answer this question, guys? Okay, this question is again a very good question. So please try to answer this question. Yes, because I can give you a couple of minutes also, because this session is live session, so everybody can interact. Okay, yes. So what they have given here is statement first is given as I smooth twice. Okay, I smooth twice differentiable function can have a global minimum. Okay, and all smooth twice you can say differentiable function has, what is the meaning of twice differentiable? Okay, that you have to understand. Okay, so yes. Please try to solve this question. Option A is P and Q are true. P is true here. Okay. And this is going to be a question number 35 from your actual paper, right? Understand? Yes. So please try and tell me the answer so that we can proceed ahead. If anybody is live right now, fine. So what we can do here is we can see what they have written. Again, read it. Smooth twice differentiable, right? Two times differentiable, right? Can have global maximum minima. All smooth. Okay, so smooth means what? What is the meaning of smooth here? First of all, that you have to understand. If a function is smooth one, right? If a function is smooth one, means what? It will be continuous, right? It will be continuous and it will be differentiable also, right? Okay, so yes. So what you can do here is an all smooth function. So this statement can go wrong also. See, because all is written here, right? Okay, all is written. Understand? So you can say that a smooth twice differential function can have global minima, right? But not all such function necessarily have global minima, right? So this option, because of this all, right? Q can be wrong, and wherever Q is present, okay, that option is gonna be wrong, right? So remember that here they have said Q is true, which is wrong. Okay, Q is true, which is wrong, right? And here both are wrong. Okay, they have said matlab this will be wrong. So which option is going to be correct here? Option B, right? So it is a concept based question, right? So I hope everybody understood this. Okay, so you can also take some examples and you can then you can verify this. But here, if you know the concept, since they are saying that for all, they are giving you generalized statement. All smooth twice differential function have global minima. This can be wrong also, right? So if you take any polynomial, right, if you can take any quadratic polynomial and you can differentiate two times. Okay, so you can get global minima over there, right? Okay, so this is one of the very easy question, and okay, and you can get the answer, right? Yes. So P is true and Q is false, right? So if you take f of x equal to ax square plus bx plus c, right? So this can be twice differentiable since it is smooth also, right? Okay, but not all, smooth twice differential functions have global minima, right? That is what you have to keep in mind. Let us move to next question. Fine. So this was one of the very good question, guys. You see, okay, this question is from optimization again. Optimization again. Optimization for single variable, right? Optimization for single variable. So a company is manufacturing a product at the rate of P unit per day, right? What they are saying is company is manufacturing a product at a rate of P unit per day, right? The cost per unit is given here. They have given here cost per unit, that is C equal to 50 plus 0.1 P plus 9,000 slash upon P. The selling prices per unit is given. They have given the selling price here, that is nothing but 300, right? So you know uh, and the production level minimizing. So if you want to find the selling price, okay, so you can multiply with P, right? Because they have given 300 here, and 300 is nothing but selling price per unit is given as 300. The production level minimizing, the moment you see this kind of a word, minimizing the cost per unit, okay, so you have to understand that this problem belongs to optimization, okay, where you have to use the concept of maxima and minima. Okay, where you have to use the concept of maxima and minima. Okay, yes. What we can do here is we can consider this cost. So what they are asking is the cost per unit, okay, the production level minimizing the cost per unit, and the total profit per day. You have to find the total profit. How can you find the total profit, guys? How can you find the total profit, since profit can be achieved when the selling price is larger than the cost price. Okay, that everybody knows, right? When the selling price, so some sort of aptitude also you have to use here, right? Some sort of aptitude also you have to use. So first of all, what you can do here is you have to minimize the cost per unit. Okay, per unit. So what you can do here is you consider this cost here first. Let me consider C here. So C is given as 50 plus 0.1 P, right, plus 9,000 upon P, right? This was a cost they have given, right? And since you have to minimize the cost per unit, okay, so what you can do here is you can differentiate this, right? So dc by dp you have to do, because this cost is a function of p, okay? So you differentiate this, okay? First derivative you have to find. So this is nothing but a first derivative. So constant differentiation is 0, and this becomes 0.1, and this become, it will give you 9,000 by p square, right? If you're going to differentiate 1 by p, so 1 by p is nothing but minus 9,000 by p square. Now you have to find the stationary point, guys, in order to find this p value, right? So what you can do here is uh, you take this guy as 9,000 by p square equal to 0.1. Now you can say that p square is going to be 9,000 by 0.1, which is nothing but 9,000, okay, by 1, right? So here you can find p is nothing but square root of 90,000 here. That will give you 300. Okay, you don't have to consider negative value because cost cannot be negative, guys. Okay, so this p should be positive here, 300. Okay, so I think you can directly go back to the options. So these options are now gone, right? Because here they have given, you can see that the cost per unit they have given is dp by dx is going to be what? P is going to be 150, okay, 300. So option A and C, there is a fight between option A and C, right? Option B and D cannot be correct here, right? So this is the answer that 300 you have got. Okay, so since you have got this p equal to 300, so what you have to do here is you have to go for second derivative also, right? So that you can check whether this is a minimum price or not, I mean minimum cost. So d2 c by dp square, right? So if you're going to go like this, so this becomes minus 9000, okay, minus 2 by pq. Okay. Now if you're going to multiply this, so it becomes 18,000 upon pq, right? So I believe this is fine for all, right? Now you can plug 300 in place of, okay, so this is going to be positive only, guys, right? This will be positive, right? So second derivative is positive, means that is the correct value, right? You will get positive value if you're going to plug here in place of p 300. So I think this is clear. Okay, so this is very important concept. Okay, so first answer is going to be 300, right? So you can eliminate option option b and d. Now let us try to compute the total profit per day. Okay, we have to find total profit per day, right? So what is total profit here? Total profit we have to find total profit. Okay, you can say is going to be equal to, okay, selling price is nothing but what? Selling price is 300 times p, right? Okay, minus, because as I told you that how can you get the profit? Profit can be achieved when the selling price is larger than the cost price. So absolute profit you can get is, this is nothing but a selling price times p minus, you have got the cost price, that is 50 plus 0.1 p, okay, plus 9000, okay, times upon p times p, right? Okay, so now what you can do, you can further simplify this guy. Okay, so I think this can be achieved. You can say this is t, so 300p minus 50p plus 0.1 p square. Okay, since you are taking this minus sign also inside, so this become minus only, and this become 9000. Okay, I believe this is fine, guys. Okay, so this is the correct one that you can get here, right? So what you can do here is you can subtract 300p minus 50, that is going to be 250p. Okay, so finding p value was very easy, direct, and second also is very simple. Okay, so minus 0.1 p square minus 9000. Okay, this is very simple one. Now what you can do here is you can differentiate again, because you have to find profit here. You see what they have asked. You have to find total profit per day, right? So you have to differentiate with respect to again, p, right? So you differentiate this guy. So what is the differentiation of this dt by, dp, which is nothing but 250 minus 0.2 p, which is equal to 0. So p will be what? 250 by 0.2, right? Okay, so you can just find out, right? So what is the value here? P is going to be 1250, right? Okay, and why we are differentiating this? Because they have said minimization. Now you have to check also, okay, whether this value is correct or not. So this option a is going to be correct for this question, right? 312.50, right? But anybody can solve it, right? If somebody is not from data science and AI, they can also solve this problem, right? So you can check also if you want to check for second derivative. What you can do here is d2 t by, okay, this is very important, right? Okay, but there is some sort of contradiction also you will get if you're going to go for second derivative, right? So the second derivative comes out to be negative also, that you have to keep in mind, right? Okay, that is very important to remember. So there is a contradiction, right? So they must have told here in this question there is a problem also, right? Key, the total profit per day you have to find maximizing the cost, right? Like that they should mention. Okay, but what they have mentioned is minimizing only. So but still you are getting this answer, right? Because if you're going to go for second derivative here, so you will get some sort of maximization, right? So in this sample paper, there is something, there is a problem in this question, right? But still you can consider this. Okay, since that statement is not given, so okay, you can consider this as option, right? So my main job is here, guys, of this session is to make you familiar how to attack to the problem of data science and AI mathematics, right? Because the weightage of data science and AI mathematics is huge. 35 plus 35 marks you can obtain, right? So let us move to next question. One of the very good question, you can see the value of real variable, x greater than 0, which maximizes. Again, they have given the word maximizes. Again, this is a topic, this subject, this question is from optimization for single variable. Okay, understand. So the value of real variable x greater than 0, which maximizes the function. Okay, so they have given f of x here, and so you see what are the topic they are going to touch here in the sample paper. They have touched. They have touched maxima, minima, like optimization problem. They have touched limit. Okay, and you see this question is again here. So f of x is okay. So first of all, we have to go for the same procedure, right? So first find out f dash x. So there are two functions, you can say x to the power e raised to power minus x. Whenever any function is given, go for first derivative without any phobia, guys. क्या होता है ना कि we stare at the question. अच्छा ये question क्या पूछा है, right? We must start solving it. Okay, if you are going to stare at the question, nothing is going to happen, right? So you start derivative, find the first derivative here. So first, keep this guy as as it is, x to the power e, and then differentiate second, so it will give you minus x. Okay, again you keep the second guy as it is, minus x, and differentiate this guy. So you can consider this as x to the power n. What is the differentiation of dy by dx x to the power n, guys? N x to the power n minus 1. I believe everybody knows this. Okay. So what we can do here is we can differentiate this, right? So it will be e x to the power e minus 1, right? The moment you got first derivative here, so you can find the critical point. Okay, so what is the critical point, guys? Set the first derivative, okay, f dash x equal to 0 in order to find the stationary point, you can say, for stationary point. Stationary point, right? Okay. Now what we can do here is uh, we can write this guy as it is. Okay, so let me manipulate further. So this is nothing but minus x e to the x to the power e raised to power minus x, right? Plus e raised to power minus x. Okay, x to the power e minus 1, right, equal to 0. So let me further manipulate this guy. So what you can do here is you can take something common here, right? So if you take something common, so what you can take common here, guys, you can take common as uh, you know you can take common as what, minus e x to the power e, you can take common, right? And you can take e raised to power minus x common from here. So what is this here, guys? Okay, so if you're going to see here, this is very important. So you have taken 1 here, right? And x to the power e also you have taken here, right? So what you can do then, minus, right, you have taken this already out, and from here you have taken x to the power e, right, out. So it is nothing but 1 by x, right? So e x to the power minus 1 equal to 0, right? So further if you write this as, right, so x to the power e raised to power minus x, 1 minus e by x, okay, equal to 0. Now if you want to make these guys 0, right, so better you can equate this guy to 0, right? Don't equate this, okay, because x to the power e cannot be 0, right? E raised to power minus x will be 0 when you will put x equal to infinity, but you can't put here because x cannot be infinity here, right? So what you can do here is you can equate this, because many of us get stuck here, right? Or how to solve this, right? so 1 plus e by x is going to be 0. So what is the value of x here, guys? X is going to be e, I believe, yeah? If you take this, x is going to be e. Okay? It's a very simple question, right? X, so your stationary point is going to be x to the power e, okay? Which is nothing but, so you can go for second derivative also, right? If you want to check, okay, second derivative, understand? So you can go for second derivative also, right? So x equal to e here we are getting, right? But what we have to find here is the value of the real variable, the value of the real variable x, which maximizes the function f of x, right? So let us go for second derivative here, okay? Then we can decide. Right now we can't decide. So f double dash x we can find out. So that is nothing but x to the power e, right? E raised to power minus x, then 0 minus e by x square. You just differentiate second part. I mean, I'm just differentiating this, you can say. This I'm differentiating by simplifying. You can say this is nothing but your f dash x, right? So I'm just keeping this as it is, and we are differentiating this first, okay? Then what we can do here is, we can write this as, okay, so let me write, this is nothing but plus minus 1 plus e by x, right? F dash x, right? Okay. Now you can just f dash x, okay? You can put in place of x e, right? So this is nothing but e raised to power e, right? E raised to power minus e, okay? Minus e raised to power e square plus uh, minus 1 plus e by e, right? And this is nothing but f dash e. So this becomes 0. Okay, this will become 0, guys. Okay, why? Because e by e is 1, so this becomes 0 completely, right? So if you're going to see here, if you're going to simplify this, what is this? E raised to power e raised to power, this is 1, and from here you will get 1 by e, right? And this is nothing but less than 0. Certainly x equal to e, right? At x equal to e, it is going to be maximizing. So what is the value of e, guys? That is going to be the answer for this question, right? So the answer for this question will be, okay, because this is the maxima situation, right? Maxima, because second derivative is coming out to be no. So the answer for this question will be what? What is the value of e? So x equal to e. Now you should know what is the value of x equal to e, right? So that becomes 2.718, and they're asking up to two decimal place. So you can say that 2.72 can be the correct answer for this question, right? So I hope this makes sense to everyone. Okay, guys. So we have done this entire question of you can say calculus from data science and AI paper. In coming session, we are going to also talk about probability and statistics questions. We have done linear algebra session. Okay, so you guys might have attended. So yeah, so I hope everybody might have enjoyed this session for today, and I will recommend everyone, not only for data science and AI, for all branch of engineering, they must join this session, learn, watch this session, and learn a very good technique from the other, right? You see here, guys, all concepts are really appealing. Okay, whenever I solve some this kind of a problem, I feel appealing, right? So please remember that we have discussed many. Okay, this question was amazing question, you can see, right? So fine. So we'll meet in the next session, guys. Thank you so much for today. And okay, our next session is going to be probability and statistics. Thank you. All the best for GATE DA and other branch of engineering as well. Okay, thank you.